Hello, everyone. Good morning, afternoon, evening. I hope I'm audible.
Yeah, audible.
Harsh, am I audible?
Yes, Priyanshi, you're audible, please.
Hi, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 6D. Myself, Priyanshi Goyal, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2025, Pune, India. The 9th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Pune, India, and the virtual event is being held through Zoom today and tomorrow, that is 30th and 31st January 2025, through the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentations and 2 minutes for question and answers. On 7 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me in chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Rajan Patel. Just a second. Yes. Dr. Rajan Patel is currently serving as a principal at Kalol Institute of Technology and Research Center, KIRC, Kalol, Gujarat, India. He has more than 19 years of academic experience in the field of computer science and engineering, and is also associated with the IT industry. His main areas of interest are intelligent data, applications and communication, information security, IoT, and cloud computing. Thank you so much, sir, for joining us to chair this session. I'd now like to invite Dr. Rajan to share a few words of encouragement with our attendees as we begin this session. I think there's some network error. Dr. Rajan?
Rajan sir, am I audible to you? Rajan
Harsh, you're
sir?
audible, but Rajan sir isn't.
Okay, no worries. Priyanshi, you can start the session with the presenters, right? I will just
Okay,
talk with him.
sure. Okay. So without further ado, let's move in with the session for today. I would like to start with I would like to invite Sanya Shri to present her paper titled Advancing Connectivity, a comprehensive review of mobile networks from 1G to 6G. Do we have you here with us, Sanya?
Yeah, hello.
Hello?
Yeah, am
Yes.
I audible?
Yes, you're audible. I will stop sharing so that you can start your screen share.
Okay. Should I share my screen?
Yes, please.
Please let me know if you can see.
Yes, your screen is visible.
Okay.
You
Hello.
can start.
Okay. Hello, good afternoon, everyone. It is an honor to be to discuss the most transformative advancements in human history, mobile networks. From 1G, which introduced voice communication, to 6G, which will integrate AI, quantum computing, and ultra-fast communication. This journey has been remarkable. Today, I'll cover the evolution of mobile networks from 1G to 6G, the impact of 5G in industries like healthcare, defense, and education, the key enabling technologies shaping the future of connectivity, and the challenges of future direction of 6G. So let's begin. The evolution of mobile networks has played a pivotal role in shaping modern society, each generation of mobile communication has introduced new capabilities, increased data speed, and enabled global connectivity. Key advancements include 1G, analog voice calls, 2G, email, SMS, and multimedia messaging, 3G, internet access and mobile broadband, 4G, high speed HD video streaming, and seamless
Uh,
connectivity.
Sorry, Sanya, your screen has not changed. It's still on introduction.
I'll change accordingly. Hello.
Yes, sure. Please go ahead.
HD video streaming and connectivity, 5G, ultra fast speed, low latency, and IoT integration, 6G, AI driven smart network, ultra high speed terahertz communication, and quantum computing. In this presentation, we'll explore how these industries and what the future holds for 6G. Now, let's begin with the evolution of mobile generation. Now, as we know that 1G is the analog beginning, analog voice message communication with poor security and limited to voice-only services with bulky mobile devices. 2G includes the has digital revolution. It includes the shiftage from analog to digital signals, improving call clarity, introducing SMS and MMS, enables secure communication with encryption. Now, the 3G mobile introduced which introduced mobile broadbands, video calling, and internet browsing on mobile devices, laid the foundation for smartphones and mobile apps. Now, 4G is the age of ultra high speed connectivity. It enabled the HD streaming, real time video calls, and cloud computing. Faster downloads, seamless connectivity, and low latency improved user experience. The 5G was the age of ultra high speed connectivity, 10 to 100 times faster than 4G, with speeds up to 20 Gbps, enables IoT, smart cities, real time remote surgeries, and autonomous vehicles. Now, the 6G includes the future of connectivity, AI powered networks, quantum security, and ultra high speed terahertz communication, which aims to connect everything everywhere with near zero latency. Each generation has pushed the boundaries of technology, improving communication, automation, and connectivity. Now, let's move on to 5G and 6G, especially. Increasing data rates, decreasing latency, which simply means with each generation, data speeds have skyrocketed and latency has decreased significantly. 5G enhances connectivity through IoT integration, AI driven application, and ultra low latency. 6G will introduce quantum computing, smart AI driven networks, and terahertz communication, which making connectivity faster, smarter, and more secure than ever before. Imagine a world where holographic communication, fully autonomous AI systems, and seamless smart city integration become reality. This is what 6G aims to achieve. Now, some of the applications of 5G include the healthcare, which is the future of medicine, remote surgeries with robotic assistance using ultra low latency 5G, AI powered diagnostics for real time patient monitoring, telemedicine, and wearable health devices for health. Now, moving on to defense and security, warfare, 5G enabled battlefield for secure real time data exchange, AI powered autonomous weapons for next gen defense systems, advanced surveillance drones, and robotics for broader security. Education, smart learning, virtual and augmented powered by 5G, AI powered personalized learning, adapting education to student, global access to high quality education, bridging digital divides. Moving on to the industrial IoT, the fourth industrial revolution, smart factories with AI driven automation, autonomous logistics, and supply chain managed with time monitoring, energy efficient smart grids for sustainability. 5G is not just about faster internet, it is a more connected world. Now, moving on to enabling 5G and 6G technologies, AI and ML enabling self optimizing and self healing networks for efficiency, AI driven threat detection. Blockchain provides decentralized authentication for prevents data breaches and cyber threats in mobile communication. Edge and fog computing reduce latency for processing data closer to the user, enables real-time applications like autonomous cars and surgeries. Quantum computing introduces quantum encryption to make hacking nearly impossible, optimize data for ultra-high speed. Advanced antenna systems, massive MIMO improves signal strength, reconfigure uh, intelligent surfaces, optimize wireless transmission, drive the transition to 6G, enabling a hyper-connected and intelligent ecosystems. Future directions, energy efficiency, which 6G aims to be twice as energy efficient through AI-based power management and mobile networks. Security and privacy, quantum-resistant cryptography, protect future mobile networks from cyber threats, infrastructure deployment, high cost and regulation must be to enable global 6G adoption, and the vision of 6G near zero latency, extreme integrated smart networks, and intelligent automation. The future of connectivity is not just about speed, it's about efficiency, security, and intelligence. Now, in conclusion, we can summarize that mobile networks have evolved significantly from 1G to 6G, shaping our digital world. 5G has transformed industries with ultra high speed AI integration and IoT connectivity. 6G will introduce intelligent, AI driven, ultra fast, and highly secure communication. The future will focus on smart, sustainable, and efficient connectivity. The next decade will redefine how we connect, communicate, and innovate. Thank you all for your time. I look forward to your questions.
Hello.
Hello.
Yes, may I audible?
Yeah,
Please show me your list of references.
list of references. For
Reference list.
yeah, reference.
Okay, fine. Is it not in PPT? Okay, leave
No,
it.
it's not.
Leave it. How many of number of references have you used in order to prepare this manuscript?
I guess around 12 to 15. I'm not sure about the exact number.
Right. So in that case, see, for any research work, 12 to 15, these are the not sufficient. Minimum, you have to be considered 12, 20 to 0 number of list of references. And the second thing I would like to highlight, you means mention that you have to highlight the in-text slide citations. Just
Okay.
go back, right? For example, go application of 5G, right?
Excuse me, sir, your voice broke. Can you please repeat?
Okay. For example, here you mention, challenges of 5G. What
Um,
are the challenges of 5G? These are the listed challenges of 5G. Yes or no? Hello?
yes, sir.
These are the listed challenges for the 5G network, right?
Yeah.
Who says energy efficiency, security and privacy, these are the challenges? Are you saying no? Who says, who's listed these challenges?
Sir, I'm not able to listen. Your voice is breaking continuously.
Sanya, his voice is right. Like it's audible to us. It's
Uh,
not breaking.
yeah, I mean, it's audible after a few
Okay, anyway, but you have to be focused on a list of references and citations of your work.
Okay, okay,
Okay,
okay.
okay, thank you.
Yes, sir.
Okay,
Hello.
thank you. Next one, please.
Thank you so much.
Okay, so next we have just a second. I'll just just a second. Okay. Next, we have Shraddha, and she's going to present on anomaly detection in videos for chain snatching using meta learning. Shraddha, are you there?
Yes, I am there.
Yes, you may please proceed with the presentation.
Yeah, sure. Yes. So is my screen visible?
Yes, it is visible.
Yeah, thank you. So I am Shraddha Naik, research scholar from Amrita Vishwa Vidyapeetham, Bengaluru. And on behalf of all my co-authors, I would like to thank, first of all, I would like to thank the organizing committee of SMARTCOM 2025 for giving us the opportunity to present the paper entitled Anomaly Detection in Videos for Chain Snatching Using Meta Learning. So this is the brief outline of my presentation. So I'll be giving the introduction of our work, the methodology and algorithm briefly, the schematic representation, and then I'll be going ahead with the results section, a comparison with the other techniques, and the conclusion. So to begin with, our work is based on detecting anomalous or suspicious events from surveillance videos. So the paper which we have worked on, it is focusing on detecting crime of chain snatching videos. And the major gap which I observed in most of the literature survey, whatever we had done, is that there are a lot of videos available, video data set available from Western context, but from Indian context, there are very limited data set available. And that too, we tried to incorporate a data set which in the previous literature work, people have not done. So we explored this new data set of chain snatching videos, which is very, very common in especially Indian context. So it was quite challenging to create the data set. So that was a major gap in the work. And we introduced a technique called model. This technique is already being used in many of the work. So we fine-tuned this technique called model agnostic meta learning. And the basic objective of this technique is to work on a data set which is smaller in size. So most of the machine learning or deep learning algorithm, they will need a very, very huge data set for training purpose. But meta learning has this ability of detecting or uh, doing any sort of prediction with the very limited data set available. Because the data set what I got, what I created, that is chain snatching videos, it was hardly around 20 videos, but still it was able to do the prediction very well. And the hypothesis of this technique was to like we took two different data sets for training and testing. For training, we use the same data set which was used in many of the work before, that was UCF data set. And for testing, we took altogether a very different data set, chain snatching, which was not used in the training. And that we developed an algorithm called as sampling based meta learning anomaly detection. Uh, why sampling based? I will explain in the algorithm part. This algorithm itself had a lot of randomness in it. So there was a lot of stochasticity in the algorithm, which gave us the good results compared to the other work. So I'll just briefly explain this algorithm. So here, there are two major parts. One is meta training and meta testing. These are the two major parts of the algorithm. And you have the training domain, which is being divided into abnormal and normal classes. So what happens here is, since I mentioned there is stochasticity in this algorithm, that is, there is a lot of randomness. When you are creating normal set and abnormal set, at every iteration, the sampling will change. Like there is random sampling to construct a normal data set as well as to construct a abnormal data set. So at every iteration, you will get a different pairs of normal and abnormal videos. That is the main idea, the core idea of this algorithm. There is randomly sampling of the normal and abnormal classes. And apart from that, there are hyperparameters like alpha, beta, gamma, which is nothing but the learning rate or the step size. And even you can also see that the loss is being getting updated, because again, this algorithm, since we mentioned you want to optimize something, so definitely the gradient descent part also comes into picture here. But the major idea here is to do random sampling, and that is why we have named this algorithm also as sampling based model agnostic meta learning for anomaly detection. And also there is one more concept which we introduced. uh, Although there is internal iteration, but we also have kept something called as global iteration also, because since we are going to run this algorithm for multiple number of times, so there will be multiple checkpoints which will be created. So this is a schematic representation of the algorithm. So we are taking raw videos, and even whatever chain snatching videos I've collected it from YouTube. So I had to do a lot of pre-processing and trimming the videos or cropping them, and most importantly, feature extraction on all those videos. Not only testing, but also training videos as well, which were around 800 plus videos. And then we did class labeling, and after that, as I mentioned, the algorithm, there are many iterations. So I've shown this in the diagram. So in every iteration, you do meta training, meta testing, that is random sampling of the normal and abnormal videos. And for every iteration, we'll get a checkpoint, which will give us the AUC and accuracy. So we are going to select the checkpoint which has got the maximum AUC. So that we get, so we are getting a spread of all the AUC and accuracy values. Apart from that, I also checked parameter sweep results. That is, I wanted to see how if we change all these hyperparameters along with even iterations also. Uh, so we got very good result as 86% for accuracy and AUC for 84% for around 200 iterations, and alpha was 0.001, beta was 0.1, and the learning rate gamma was 0.01. So we did this hyperparameter tuning as well to see the better results. So this is a snapshot of the spread of accuracy in UC histogram. As I mentioned, the algorithm is not just one iteration, single iteration. There are internal iterations also, and there are global iterations as well. So we have plotted this histogram just to indicate what is the spread of the accuracy and AUC over the number of iterations. And this is a snapshot we have taken for the best result what we got. And global iterations, that means we have run this
This is
algorithm.
a 7-minute reminder.
Yeah, 100 times. So we got 100 checkpoints, and the best result, as I mentioned, 86%. Technique with other techniques. That is, these were the two papers which we have compared our work with videos. Um, this is the ground truth and prediction result. So the blue curve indicates the actual value, and the orange curve indicates the prediction value. This is our work, result of our work, and it clearly gives the very good result here. You can see the prediction and the ground truth clearly. It is not matching perfectly, but it almost matches approximately. And we also tried it with the other results. These are the results of the other two methods, that is RTFM. And this is one more missed multiple instance self-learning. This is another paper for which we have compared our work with. And we found that that work did not give us good results. Like here it is completely missing. The orange curve is for prediction and the blue curve is for the ground truth, that is the actual value. And we tried to use our same feature extraction technique on this method, but it gave us very bad results as compared to our work. This videos, I have just taken a screen grab, a snapshot of the two chain snatching videos, and I'm trying to show the
Shraddha, can you just wrap up? We have already crossed the time limit.
versus, yeah, prediction results. So that's all. Result what we got was 86% for accuracy and 84% for AUC for chain snatching data set. And the major conclusion here is the meta learning method, what we have used, it is able to generalize a very new open data set very well, which we have not used in the training data set. So, and these are the references which have been included. So there are even more references, but yeah, that's all from my side. Thank you.
Hello, Shraddha madam, may I audible now?
Yes, yes, sir. Yes, sir.
Okay, ma'am. See, the work is okay, fine, good. You included, you are following the, research ethics also. You included these research, I mean, the citation reference listed also, right?
Yes.
But I have one question that is raised in my mind. The
Yes, sir.
work that will be detect, chain snatching. It will
Yeah,
be
yeah.
work, live, or say, will it be work later on?
Yes, sir. Actually, we are even trying to extend that work like prediction.
Hmm.
Right now, it is just detection. There are already videos which are there in YouTube or any other source, and it is detecting where exactly the anomaly has occurred. And also,
Hmm.
one more important point, we wanted to see how this meta learning can capture something which was not there in the training data set before. There are already a lot of techniques like deep learning, machine learning algorithms which are doing this anomaly detection, but they are using the same data set for training and testing as well, or almost similar data set. But we tried to use a completely new unseen data set in testing, just to see whether it can generalize a very open unseen data set or not.
Fine. And one more query, that is the suppose we are predicting,
Mhm. Yes, yes,
so
sir.
what happens once the algorithm itself will be able to predict it, 80% that will be a chances of the chain snatching.
Yes, sir.
Then what will be the next
Uh,
steps?
Yeah, so actually in our research work, we also, we are thinking of incorporating modules wherein we can give some alarm to the PCR that if not chain snatching, maybe some other videos also, some riots or something, wherein it can like police can be alerted that okay, some suspicious activity is going on in this part of the area. So that kind of work we are thinking ahead. So uh, that can be incorporated. Right
Right.
now, it is
So in
just the
that case, I'm giving you
detection part.
suggestion. In that case, I am giving you suggestion what you can do
Yes,
it. For example, in the first figure, it's showing, a bike. The fellow is riding the bike, and the second behind that fellow seated that is snatching the chain from the lady, right?
yes, yes, sir.
So in that case, what you can do, these are the example. In what we can do, we can extract the other features also. Once the algorithm itself it is able to predict it, there would be a chances of the 80% of the chain snatching. So immediately
Mm-hmm.
your algorithm should generate the alarm, right? Inform to the
Correct,
nearby
correct.
the police station also. Even though algorithm itself has to also capture the a number plate or say features, it has to extract the other features. For example,
Mm.
bike or car is there. I mean any kind of other things that can be paid, right?
Yes, yes,
And
yes, sir.
if the face is visible from the people, I mean from the person, so that can
Yes,
be also possible. So you can add on that like that kind of these facilities, so that
yeah,
can
yeah,
be easy to trap that people, right?
yes, sir, yes, sir.
Okay.
Definitely, sir. Yeah. Thank you, sir. Thanks for your
Welcome.
suggestion.
Thank you so much.
Yeah.
Moving forward, I would I would like to invite Sanal Kumar to kindly present his paper titled DS Predict, a novel approach for accurate identification of eligible PhD subjects. Do we have you here with us, sir?
Yes, madam.
Okay. So I'll just stop sharing. You can present your screen now. Yes, your screen is visible. You may start.
Okay, thank you. So I am Sanil Kumar SP, working as a research scholar in the Department of Future Studies, University of Kerala. The work is a combined effort of Sri Arun and myself. Arun is a scholar in Computer Science Department of University of Kerala. Thank you, SMARTCOM organizers, for giving us an opportunity to present this in your international conference. The title of the paper is A Novel Approach, DS Predict, a Novel Approach for Accurate Identification of Eligible PhD Subjects. The agenda for the presentation is, we'll be covering introduction, literature survey, problem statement, objective, methodology, results analysis, conclusion, and references. A small introduction. Education plays a pivotal role in shaping every aspect of life. The postgraduate students, after completing their postgraduate studies, mostly they want to do research. They go and meet the concerned department teachers and then find out the avenues for research. And mostly it's a laborious process as far as the experience that we have counted here in the University of Kerala. And most of the universities in Kerala, when I did a survey on the study, where I found out that many research scholars, prospective research scholars, are not having a key focus on what to do and how to do. So there's a knowledge gap that exists as to what area can be suggested and whether they're eligible for doing research in a particular area. So that is the basic underlying scope for our research. So this knowledge gap can have far-reaching consequences, influencing the research trajectory and contributions to the field of study. To find the solution, we conducted a case study on the process of determining eligibility and suggesting subjects to the PhD program of University of Kerala. The literature survey we did, there are some works, but not many. We could identify works which are aligning with this, like, say, if you have your skills, what career can you choose? Maybe the courses, choices of students and what major they can choose. And the third one, analyzing the critical phase of secondary education in India, during which students are required to choose a major stream that significantly influences their future careers. And the fourth one, machine learning model for students choose subject in Sri Lanka based on data collected from job holders. So a wide literature survey was conducted, but unfortunately we couldn't find anything that covers PhD eligibility subjects and their maybe the future, the prospective area that can be suggested for doing a research. So there's a long gap in this. The problem statement, the admission process for the doctoral programs offered by most of the state universities in India is complicated, difficult to understand, as well as time consuming. Manual process is still used for decision-making, creating inordinate delays and inefficiency. Objective is to employ machine learning model to make decisions faster and accurate, and then display list of subjects the candidate is eligible for pursuing research based on their qualification. Small description about the existing methodology in most of the universities. Applicant, after submitting the application for eligibility certificate to the university, the concerned administrative section verifies the documents. Whether the eligibility is already issued or not, they'll check, and if it is issued, they'll clearly issue the eligibility certificate. Else, if it is not, the documents will be forwarded to an expert committee for approval. That takes again time, sometimes a long delay in taking a decision. After, if the candidate's eligibility is not found apt to continue the research in a particular area, the issues, they'll reject the applicant. So we have come out with the innovative model, DS Predict. We have a data set where we have churned a data set from the applicants during last 4 or 5 years. And then we have a pre-processing module, which pre-processes the data. The training data is generated from the pre-processed data. The training data is split up into two, one for the regular subjects and the other for the interdisciplinary subjects. The data is then, the regular subject data is trained by using various models. And we have come out with our model, which is called R model. Similarly, the interdisciplinary subjects also, we have a model generated for which is called I model, interdisciplinary model. And the evaluation is done by testing it out, which based on the PG postgraduate candidates application, which is apt for the doing research. And that was evaluated. So the data sample total size is 2,768 collected from various departments of University of Kerala, categorized into 62 subjects across 13 different faculties. The analysis of the machine learning models that we have used, we have used 5 different models: gradient boosting classifier, decision tree, random forest, extra tree classifier, cat boost classifier. The R model gives, when it was trained, it has given an accuracy of about almost centering around 98%, and the evaluation centering around 97%. Whereas the I model, the training accuracy was a little bit lower at 92-93%, and the evaluation pegging around 90-91%. A demonstration of the results that we have done. If a candidate is having an MTech computer science with specialization in digital imaging computing, and the qualification, eligible qualification is UGC NET computer science, the predicted PhD subject by the model will be science, computer science and engineering, and applied science and under the applied science and technology faculty, you have the technology management. Similarly, if a candidate with MSc physics and GATE qualification is there, the predicted PhD subject would be physics. And in applied science, which is an interdisciplinary stream, applied science and technology, you will have the optoelectronics. Now, we have chosen MSc Botany, MSc Maths, and MA Economics. Now, coming down to MSc Mathematics, educational qualification is CSIR, UGC NET, and JRF Mathematics. The predicted subject will be mathematics and, say, future studies for doing
This is a gentle 7 minutes reminder.
Okay. Conclusion is DS predict model accurately predicts suitable PhD subjects for candidates. Applicants gain invaluable insights into eligible research subjects, broadening the research opportunity, significantly streamlines the eligibility process, improving the efficiency of the doctoral program admissions. Stakeholders can make more informed decisions, while applicants can confidently select their research interests, leading to better resource allocation. List the references listed. Now the floor is open for discussion. Please, if you have questions, we are ready to answer.
Yes, sir. Hello.
Yeah, sir, please.
I have one question. That is, why DS predict model only?
Why DS predict model only? Yeah, the model
Yes.
is useful.
There are many other models are there.
Yeah. Yeah, we say because that is the tree-based model which is most we have tested, and the tree-based ensemble model which is more apt.
Who tested? Who tested? Who tested? You tested, or is some other researchers tested?
The research, the
See,
review.
in this case, I'm giving you just example. What you can do it. See, DS predict, that is the one of the model. Similar that way, there are many other models are there. So in that case, what you have to do, you have to find out the which model, which kind of the prediction model would be a preferable for your work, right?
Yes. Yes.
So based on that kind of the survey, you have to select the particular model, right?
Yes.
And second one, second questions, the title, that is, identification of the PhDs, I mean, identification of the PhD students, na? In PhD subjects, you mentioned the PhD subject.
Yeah.
So you are identifying the types of the students who are the eligible for PhD in engineering, or say PhD in computer science, or say PhD in psychology, or say history, like that way?
No, if a PG applicant, if the postgraduate degree with eligibility is given, which all streams are eligible to do research, whether it's in the regular stream or he can do research in the interdisciplinary stream also. So we want to help him to find out different avenues where he can do research,
ठीक है, okay, fine.
which is absent. Like when we went to register our subject, there were many hassles because nobody could actually guide us. So that was actually the turning point for doing this particular work.
Okay, ठीक है.
Thank you, Sanil.
Thank you.
Can you stop presenting? I'm not able to turn off your screen. Can you just stop presenting once?
Yeah, one moment.
Thank you. Moving forward, I would like to request Sudha ma'am to kindly present a paper titled Sam Refine, a dynamic scene adaptive mask refinement for object segmentation and tracking in complex videos. Do we have you here with us, ma'am?
Yeah, am I audible now?
Yes, you're
Hello?
audible, but
Okay. Can I share my screen?
yes, ma'am. Just a second. Yes, you can share.
Okay. 1 minute. Is it visible?
Yes, it is.
Okay.
Can you just zoom in?
Wait. 1 second.
Yeah.
Is it visible now?
Yes, it's visible.
Okay.
You may start. Thank you.
Okay. So good afternoon to all. Myself, Sudha SK, doing postdoctoral research under Dr. Aji S in the Department of Computer Science, University of Kerala. And today's presentation is about a dynamic scene adaptive mask refinement process for object segmentation and tracking process using complex video data sets. So the presentation outline for today is regarding the introduction to the domain and problem statement, review of literature, proposed methods, results, conclusion, and references. So to start with, we know that video object detection and tracking is a very crucial task when we are dealing with the complex objects and dynamic objects with occlusions and varying illuminations. And we have know that there are several application domains for this one, like surveillance, healthcare, business analytics, sports analytics, and smart cities. So due to the advancements in the video analysis tasks and different types of these type of domains, we need to require different advanced frameworks that are capable of detecting, segmenting, and tracking objects in real time using the complex and dynamic scenes. So for this research purpose, we will be using the traffic videos for detecting the different types of objects. So regarding the type of objects, we can have a single or multiple objects, or either that will be in case of a static or a moving objects for a video scene. So the problem statement is regarding the aim of the project is to implement a novel dynamic scene adaptive mask refinement strategy for robust video object segmentation and tracking in dynamic environments. So regarding the literature review, as we can see that we have a broad two categories of video object detection methods called one-stage detection and two-stage detection. So for this work, we'll be using a two-stage detection called a MARC RCNN. So regarding the state-of-the-art methods, we have different types of frameworks available for the video object detection and tracking methods. So here we have listed few of the literatures we have done for the traffic using the traffic data sets. So from that we have some inferences that each of the methods will be using either a one-stage detector or two-stage detector or a hybrid type of detectors. And the tracking methods also include like deep sort, fair mode, GoTurn, and MDNet. And we can categorize different methodologies using a flow-based detection and tracking, segmentation detection, or attention-based or transformer-based or some other type of methods can be used. So for this work, we'll be using a segmentation type of detection and tracking method because they are very popular. And the research is very little bit complicated when compared to the ordinary type of flow type detection and tracking methods. So the real challenges involved in this type of video detection and tracking is regarding one is due to the large volume of visual data within the real time frames, how we can detect the frame time in a real time. And the other one is the complex environments like low resolution illumination and shadow effects. So these are some examples showing the different effects in a video scene. And this is the proposed method for the current study. So we have used a SMARTCOM framework for the video object detection, segmentation, and tracking method. So here we have used 4 different phases in which in the first phase we use a SMARTCOM for the instance segmentation using the ResNet 50 backbone using the feature pyramid network. And the region proposal networks are generated by SMARTCOM, and the region of interest alignment is done to extract the features. So here we have used the bounding box features as well as the mask features using the fully connected and fully convolution networks using this equation so that we have got each pixel segmented. And we have used as a temporal unit to the framework so that it can capture the temporal information from the video sequences so that we can have a specific frame at a particular time for a detection. And to fuse this spatial and temporal features, we will be using a attention-based spatial temporal attention blocks so that each frame will be given a weighted score so that it can be fused very well to coherence with the spatial data. So in the 4th phase, we are using a mask refinement phase so that each of the frame will be detected properly at the time of real-time detection and tracking. And here we have used a sigmoid activation so that it can generate a mask refinement probability map. And for the loss function, we have used a binary cross entropy loss. And the total loss function for the framework is the mask loss and the temporal consistency loss and the refinement mask. So 3 loss functions we have used for the purpose. And for the training, we have used a mixed precision training strategy so that the computationally intense methods will be working in a 16 precision unit, and the units that need more accurate results will be working in a 32-bit mode. So the model is trained for 300 epochs with an ADAM optimizer for 0.001 learning rate with a batch size of 8. And in the total 300 epochs, the last 25 epochs are used for the fine-tuning the masks, and I will be getting the refined marks for the detection and the tracking. And for the experiment, we have used 2 benchmark data sets called Kitty modes and BDDK 100K with multiple classes. And in the Kitty modes, we have 2 classes like cars and pedestrians. With both are very challenging and high resolution videos with different numbers of frames. And for the evaluation protocols, we have used different evaluation metrics like mean Jaccard index, boundary F score, combined J and F, and S modes, modes P, and the MIOE. So these are the results obtained from the research that for the Kitty mode, we have got mean
This
J
is
and
a
F.
gentle 7 minutes reminder.
Okay. And we have got very good results for the detection and tracking as per this result. And the area of under curve we have got is more than 85% for all the classes. And these are the area under curve we have got for each class. And And regarding the mask quality refinement, we have got 94.86% for the kitty modes and 92.20 for the BDDK 100. And we can see a trend of increasing the accuracy when the number of epochs are increased. So we have seen the convergence after 250 iterations, so that the total number of 300 iterations we have run for the fine-tuning the refinement process. And these are some visualization of the frames we have got from the segmentation results using this proposed method. And for the ablation analysis, we have used the
I'm sorry,
mixer.
I have to interrupt. You have already crossed the limit. Can you please conclude the presentation?
Oh, okay. So these are the loss curves we have obtained for the normal framework and the mixer precision training. And these are the comparison results with some SOTA methods, and these are the ablation studies used, different tracking methods available. So our method is very good in tracking and detecting the video frames in different complex environments when compared to the other state-of-the-art methods. And we have optimized the frameworks using mixer precision training strategy, and it is very robust tracking we have got in terms of real-time detection and tracking. Thank you. And these are the references we have.
Ma'am, just open the figure number 9 in a previous slide.
Figure number?
9, figure 9 in the result section.
Okay.
Go back.
Okay.
Back.
This
Yes, this one.
Yeah.
I have one question.
Okay.
Please don't mind. See, the work is it a sponsor work?
Pardon, sir?
Your work is sponsor?
No, sir. Not sponsored work. This is a
No, fine.
departmental.
Okay, fine.
Yeah.
Where do you live? Okay, where do you live? Where are you from,
Pardon,
ma'am?
sir?
Where are you from?
I'm from Kerala. Yeah, Kerala.
Kerala, right?
I'm from Kerala.
The Kerala state that is belonging
yeah.
to our Indian country. I mean, our nation, right? But I
Yeah,
have a question.
yes,
The work that
yes,
is
sir.
okay, fine. But that definitely will be fail in our country. The reason behind that, why I'm telling you, the images, the images or say clarity or say lightness of images, whatever they use, right? The same thing that is not applicable in our environment.
Indian, yes.
Agree with me?
Yes, sir.
है ना? So, ma'am, what I'm insisting you, you taste your work, you taste your proposed work with the real picture in the sense our country images, Kerala image.
Yes, sir. Yes, sir.
And then after taste your results. Definitely there will be a wide range of the differences is there.
Difference will be, yes, sir. Yes, sir. So
But
already we
now
have discussed that
why,
case,
why
but
we people are foreign images.
yes.
We have lots many
So
data
we'll be
sets
trying.
available, right?
Yes, sir.
So
Yes,
this
sir.
is my, please don't mind, but this is my opinion or what
No
is
problem,
the
sir.
suggestion.
Yes, sir. Yes, sir. Thank you, sir. We will take it
Our
into
contributed
consideration,
work
sir.
should be used for us, na? It should be
Yes,
our
sir.
society. It should be for our
Yeah.
nation.
Yes, sir. Yes, sir.
Okay.
Definitely.
Thank you,
sir.
ma'am.
Okay, thank you, sir. Thank you for your suggestions. Thank you.
Thank you, ma'am. Can you please
Okay.
stop presentation? Yes, thank you.
Yes.
Moving forward, I would like to request Roshan Kamte to kindly present his paper titled Empowering the Deaf and Mute with Real-Time Sign Language Translation Using Computer Vision and Deep Learning. Are you here with us, Roshan?
Yes. I'm audible?
Yes, you are audible.
Okay.
I have stopped screen sharing so that you can now present your.
My screen is visible?
Yes, your screen is visible. Kindly make it full screen.
Okay, now?
Yes, you may
Okay,
start.
Okay, just a minute. Okay, thank you. Hello, good afternoon, everybody. Today I am here to present our project title, empowering a deep and mute with real-time sign language translation using computer vision and deep learning. Our team include Roshan Kamte, Yash Gaikwad, Shubham Pawar, Kishan Chandel, and Professor Pushpavati Kanje ma'am from Department of Computer Engineering at GSPM RSCE. Now moving to the introduction part. Here our project aims to develop an innovative solution to bridge a communication gap faced by the deaf and mute individual by providing a real-time sign language translation with video call in video call. Also, motivation behind this work is so simple. A communication is a fundamental aspect of the human interaction, but people with hearing a speech face significant challenges in expressing themselves. Deaf and mute individuals primarily rely on the sign languages, but it is not commonly understood to a general people. Also, our friends have a long distance. We have long distance friends, which we do not communicate each other personally. If one of the friend can be mute, then communication will it go hard. So removing this communication barrier, we can doing a video call systems where we can communicate with through the video call. Here are the related work. Here we can refer multiple papers, but here we can show a last 10 paper that we refer. Here we can see that in the form of the table, which techniques, algorithm we can use, where the algorithm they focuses, which platform or which language they can use, which is their targeted audience, and which data set they can use. Looking at these papers, a variety of the method has been explored to address the issue. Some approaches use deep learning, multi-scale strategy, vision-based technique for the gesture recognition. Other solution involve data glows and the flex sensor, and even real-time systems like the HUD speaker. Now come to the novelty. Now we hear the things like the novelty. The first questions comes in our mind is what set our system different from the apart existing system. The simple solution is real-time sign language translation during a video call. We are integrating AI-based sign language recognition in video call, enabling a real-time translation during a natural conversation. Also, we provide bidirectional communication where our system support both gesture to speech and speech to the text for a hearing individual, allowing a seamless two-way communication. Also, the platform can be accessed through both web and mobile application, making accessible across the device and operating systems. Now come to the methodology part. Here we can use as multiple methodology. Main of these KNN, CNN, LSTM, and deep learning. KNN means K nearest neighbor, used in our project for compare a nearest and closest sign in the training dataset, where sign is trained, where training dataset allowing for a label prediction. Here, KNN use for do not go into the depth distribution. Also, we use CNN, that is a conventional neural network used for the resizing, altering, and shifting the image to add variation, and also identify the tiny portion of the image, such as a edge. Also using LSTM for the sequential input and deep learning for the classification of the image and recognizing the object in the picture. Suppose when we can showing the sign in the camera where our face is come to removing the face and analyzing the hand, we use a deep learning. Now moving to the architecture diagram. Here in the architecture diagram, firstly user open the website on the device when the camera activated for the capturing the user hand gesture. Then computer vision module process for the video feed. Our computer vision module analyzing the capture gesture to identify the key pattern. Also, two parallel work can be processed. As we can see in the slide where image processing and deep learning, two parallel work where through image processing relevant features are extracted, while a deep learning model train and extractive sign language data sets refine and recognize process can be done. In a machine learning algorithm, identify the signs where using machine learning algorithm, the system accurately recognize the sign language gesture. Next, translation using translation engine used for convert sign to the spoken language or text to the speech. and that's how our system can be implemented. Here we can implement function through the WebRTC, that is the open source available for the video call. Now, moving to the result and discussion part, where our system can be achieve 85% of the accuracy rate with the better result and static gesture rather than the dynamic ones. Also, our algorithm can be ensure fast response time in a real-time communication. And currently, our system support ASL, but the effects are ongoing to incorporate a localized language and a culturally relevant gesture. Now, moving to the conclusion and the future scope. In the future scope, enhancing the gesture recognition through deep learning, expand language coverage, including a localized language and region-specific gesture, also improving the adaptability, different environment, such as varying a lighting effect, also improve the speed, precision, and the multimode capabilities of the system. Also, in the conclusion, our real-time sign language translation system has the potential to realization in a communication for deep and mute individual through a video call, bringing the communication gap and social interaction and enhancing the independence. Here are the some references I can be shown. That references can be in previous slide, that is a related work where we can work. And thank you. Thank you, ma'am.
Thank you,
Hello.
Roshan. Yes, thank you, Roshan. Are there any questions?
Yeah, just stop.
Okay, sir.
Hello, just
Hello,
open
sir.
your architecture. Open your architecture. Slide
Yes,
number
sir.
10. Is it architecture?
Yes, sir.
Please define the architecture. What do you mean by architecture?
Sir, architecture means the overview of your project.
Mm.
Overview means how our project should be work and
It's a
stepwise.
what type of the diagram? It is the what type of the diagram? See, it is the diagram, na? It is what kind of the diagram?
Sir, architecture diagram.
Architecture diagram. Na? Suppose what happened in the step of the number, the third number step, what happened? Computer vision module, analyze sign language. Then after
Yes,
it
sir.
goes for which side? A side or B side or
No,
say
sir.
both side?
The process can be parallelly work for
It
image
works in a
processing and
parallel.
deep
So
learning.
that there has to be certain notations or symbols are used in order to show the concepts of the parallelism.
Okay, sir. Sorry, I
So
don't idea about it.
technically, this diagram, it is diagram. It is not a diagram. You can, if you want to say diagram, then that has to be a certain symbols and certain things are there, like flowchart diagrams, DFD data flow diagrams. There are different types of the diagrams are there. So
Okay,
this
sir.
figure is belonging to what type of the diagram? That is my question. If you say it is architecture diagram, so it is not architecture diagram, right? You can say it is a model, right?
Okay,
So
okay.
technically, the corrections are required in this figure.
Okay,
And
sir.
go to the first number slide, title slides. At the title slide is you use the certain images,
Yes,
1,
sir.
2, 3, 4, 5, 6. Why? What are the reason behind that? What do you want to show it?
Sir, we can show the just for the artificial intelligence and machine learning slides, sir. Not any further reason.
No, it is irrelevant to your work, na?
Okay, sir.
Am I right or wrong?
Yeah, right.
And if you are use that kind of the images, then you have to cite also.
Okay, okay.
Is it not your own images,
Yes, sir.
right?
Right.
If it is a free of scope to use, then you can use it. Otherwise, you have to cite it. You have to mention the citation source.
Okay, sir. I can care of it for next time.
See, being a student, I guess you are the students, no?
Yes, sir, student.
So these are the things, certain research ethics should be that keep in your minds. That will be helpful to you, right? If you pursue your career in a research.
Oh, okay, sir.
Okay. Okay. Anyway, thank you. All the best.
Thank you, sir.
Thank you, sir. Moving forward, I would like to request Athar Desai to kindly present his paper titled Implementation of Multi-Threaded Database for Effective Coaching Using Dynamic Data Hashing. Do we have you here with us, Athar? Athar Desai.
Yeah, I think he's here. I think there's some problem with his mic. I am Aditya. I'm his teammate.
Got it. Would you be presenting the paper?
Yeah, I'll be sharing my screen.
Okay, I'll stop sharing. So, yes, you can start sharing.
Atharva, can you please start? Uh, Ma'am, just a second. Atharva, can you please rejoin? There's some issue with his mic.
Yes, sure. Just do it a little quick.
Yes, ma'am. Yes, ma'am.
Do you want to present later? We can take the presentation next to you, the one after yours, and you can present afterwards if there's a technical
Sure,
glitch.
ma'am. Sure. Sure, ma'am. Sure.
I think Athar has joined. You can just, if
Hello.
he can present.
Yeah, okay.
Am I audible,
Okay,
ma'am?
ma'am. He's here. He's here.
Yes, you're audible. Okay.
Yeah. Please start, Atharva.
Yes.
Yeah. Good afternoon, everyone. Our research is titled Implementation of Multi-Threaded Database for Effective Caching Using Dynamic Data Hashing. I am Atharva Desai, and I'll be presenting along with Aditya Thatte and Anurag Raut. This research was under the guidance of Dr. Ramchandra Mangrulkar, and we're excited to share our findings with you today.
Good afternoon to all. The idea for this paper began when we heard the news about Redis not being open source anymore. So thus we began exploring Redis and other similar databases to understand their strengths and flaws so that we could improve upon them and incorporate them in our database. Amongst the several parameters, we primarily focused upon these 4 points. Firstly, Redis's single-threaded architecture can cause bottlenecks under peak traffic, and it is not the best use of the multi-core processors. A multi-threaded architecture solves these issues, but it gives rise to another challenge, which is synchronization. Maintaining data consistency when several threads are accessing common resources introduced considerable overhead, and it was crucial to handle it to ensure scalability. We also looked at the data structures being utilized by Redis. Redis's reliance on memory-heavy data structures like skip lists and hash tables slowed down the operations, especially during rehashing and sorting operations. And while trying to optimize parallelism, excessive thread management can lead to additional overhead. So poor thread scheduling and context switching wastes computational resources, decreasing the system performance even further. So the challenge here was to make the multiple threads coexist with minimal contention. Moving on, I would like to invite my colleague Atharva to explain the further slides.
Thank you. So we have divided the literature review into 2 parts. One is existing research and the other is existing systems. Now, many studies have attempted to enhance in-memory database performances through various approaches. One such innovation is the dash table, a data structure designed for persistent memory. In a traditional hash table, we have an array of pointers that direct to linked lists of items. But a dash table utilizes segments, which act as mini hash tables of fixed size. It eliminates the need for full rehashing and thus reduces locking overhead and improves scalability. Prefetching indexing schemes minimize cache misses by predicting future data accesses, and they're thus useful for real-time efficiency, for real-time use cases where efficiency is critical. Redis Plus was a theoretical project introduced in a paper which enhances Redis by reducing memory fragmentation and optimizing cache management. Finally, research has shown that multi-threaded key value stores significantly reduce bottlenecks and improve overall system performance. Next slide, please. Okay. Now moving on to existing systems. Redis is a popular in-memory key value database, but it suffers from 2 key weaknesses. The first one is weak hash functions, which make it vulnerable to attacks, and the second is its single-threaded nature, which limits performance scalability. Hazelcast is a distributed in-memory object store, but its reliance on the JVM, or the Java Virtual Machine, can make it less efficient in some applications. Finally, memcached is another popular distributed memory caching system, but its blocking mechanisms and data structures cause concurrency issues. Now I'd like to invite Anurag to explain the system architecture.
Hello, everyone. So as Atharva mentioned that we would be using a dash table instead of a traditional hash table. So this is a visual representation of how a dash table would look like. It would have dynamic number of segments, and each segment would have a fixed number of buckets. So we are using dash table because in a traditional hash table, what happens is when a table gets full, we need to rehash all the entries in the table again. So this operation takes significant amount of time. So we have introduced segments where a segment would whenever a segment will get full, only the particular segment will be rehashed, and all the other segments will not be affected. So this gives us significant improvement in the time of insertion uh, and rehashing. Next slide, please. Yeah. So this is system architect. This is how our system architecture looks like. Whenever a user sends a request to our database, it is transferred over a quick protocol. So we are using quick protocol because it allows us to multiplex multiple requests onto a single network call, and also it is more stable more stable and reliable whenever the network is unstable. So that's why we are using quick protocol. Uh, the quick protocol will transfer the request to our database server. There, we would have an coordinator thread which will be responsible for collecting all the requests, and this request then will be transferred to the worker thread. So a worker thread would be associated with a particular shard. We will explain in the further slides what a shard is. So this worker thread will be responsible for processing the request, and it will return the result back to the user. Next slide, please. So this is the overview of how multi-threading would look like in our database. So whenever there is a transaction, T1, T2, T3 represents transaction in the diagram. So whenever a transaction will do a request, it will first be transferred to the shard hasher. This shard hasher will be responsible for determining which particular shard contains the data it is looking for. So once it will get the shard number, the particular request will be transferred over to the shard worker. So I would explain what a shard is. A shard is a subset of a whole database, and a shard would have three properties associated with it. It would have a transaction queue, it would have a shard worker, and it would have a dash table associated with it. Whenever the dash table of the shard will be responsible for storing the data associated with the shard. The worker will be responsible for processing all the requests related to a particular shard, and the transaction queue will contain all the upcoming transactions that it needs to perform. So whenever the shard will get a request, it will be put into the queue, and the shard worker would keep on looking to the queue if a request is present, and if it is present, it will execute the request. Next slide, please. Atharva, you can carry on from here.
Thank you. So these are basically the results. The above image basically is a representation of what it looks like when we perform insertions. And the below graph shows a comparison between our database and Redis. So the x-axis represents the varying sizes of inputs, and the y-axis represents the time in milliseconds. So as you can see, we have outperformed Redis in all the various different sizes of inputs, and the value actually increases exponentially as the number of inputs increases. Yeah. Next slide. Yeah, and these are some of the references that we had used for the research. Yeah. Thank you, ma'am.
Thank you.
Thank you, team. Are there any questions?
No, please.
Okay. Thank you, sir. Yes. Next, I request Trupal J. Patel to kindly present her paper titled IoT-enabled waste bin monitoring using Raspberry Pi and cloud-based analytics. Do we have you here with us, Trupal?
Yes, am I audible?
Yes, you're audible. Uh, just a second, I'll stop sharing. Yes. Please share your screen.
Yes. Yes.
Yes, it's visible.
Is it visible?
Yes, it's visible. You may start.
Okay. Good afternoon. My name is Trupal Patel, and I, along with my team members, Mahek Viradia, Dhruvi Patel, Prisha Patel, under the guidance of Jai Patel sir and Dhruv Dalwani sir, have worked on the project IoT-enabled waste bin monitoring using Raspberry Pi and cloud-based analytics. Now, we have thought of this project because in today's world, especially in India, waste management remains a major challenge, especially in urban areas. Due to the inefficient collection, timings, and overflowing of the bins, there causes some pollution. That causes a pollution and health risk to the population of the population nearby. So this project addresses this issue using the IoT technology. So basically, we have used the Raspberry Pi platform for this. It is because, like, we have in our literature review, we have researched about, we have seen many research paper in which mostly all have used the Arduino platform, but we have used the Raspberry Pi platform first of all due to its because it is a computer, like a small computer on board, and it has an inbuilt Wi-Fi module and internet module, while the Arduino does not have that. Because of this, we have to externally attach that those things. Also, due to its size and the factor, because it has all the it has all the facilities, like it gives the USB ports, HDMI ports, like we can see here USB supply. It gives Ethernet supply, and also the GPIO pins, which help us which helped us to attach the sensors and to form this project. Now, let us move ahead. So basically, our approach is that first of all, we have attached the ultrasonic sensors and the GPS modules to the dustbins in such a way, if in two ways. If the dustbins, like we are working for the public dustbins. So if the public dustbin has the lead, then it would be placed at the top of the dustbin with the support of the lead. And if it does not has the lead, it will be attached in an angle, at a such an angle, at the top of the side of the wall in the dustbin at top. Then after the data, the sensors will collect the data, or will collect the capacity, or the data will basically calculate the capacity of the bean, and then it will send it to the Raspberry Pi, where it will be processed, and then it will be sent to the cloud platform. At the cloud platform, the data will be stored and the visualized in the form of charts, and that will be sent to the web platform which we have created, where it will be in the form of the dustbin that will be displaying the levels of the beans. Then after this, when this data will be sent, the data from the cloud will be sent to the web platform. At that time, the operator may see it in the form of dashboard, which will basically will have the notifications, like whether what is the level of the bean, and if it like it will be over the threshold value, then it will the operator will be alarmed, and they will send the alert to the truck driver to optimize that route and go to that place. So this is the flow chart, that waste bins will be having the sensors, which using the internet and all will go to the cloud storage, and then the data visualization will take place. That will be going to the operator, and the operator will be informed and the operator will further inform to the truck driver. These are the literature reviews that we have seen. In which we basically the result that we found was this only, that all others were using Arduino mostly, and we use the Raspberry Pi to speed up the processing power, and also to have the Wi-Fi and the GPS, Wi-Fi and the internet modules inbuilt. So these are the results. This is the result of the cloud platform, where the distance will be displayed, and it will also be displayed in the form of chart, and that will be this distance will be data will be stored in the ThingSpeak, and then it will be sent to the web platform, where it will be shown like this in the form of dustbin level. So these are the practical applications, like we have the hospitals now, where hospital waste, that is a biohazard waste, which can, if it is not managed, it can be very dangerous. So this project can help in the hospitals and healthcare facilities, also in the educational campuses, and all where it will be promoted the sustainable practices. And as we see that in urban areas, especially in urban areas, what happens is that in alternate days, the waste trucks come to collect the waste. But what if the dustbin gets overflowed and the waste gets on the side of the road? Then that over 50,655 tons of waste has been found at the sides of the roads, which are unaccounted. So that is why this will be very helpful. And the achievements that as I said, that the processing power of the Raspberry Pi has helped us very much. And also this will be a very good very good project for managing the waste efficiently. And in the future, this can be integrated with many sensors, like we can use the temperature sensors for detecting if there is any, like, if there is a any harmful gases released, and due to that the temperature, if temperature goes high, it will sense that. Then also we can the future work can be done is the predictive maintenance, which, like, for example, the data that has been taken in the history, and the real time data that can be merged, and from that the predictions can make that at what certain intervals the dustbin gets full. And these are the references. Thank you. If you have any questions.
Hello.
Yes.
The work is okay, fine, but I have one question.
Yes, sir.
This is kind of the generalized question. See, many of the people, I mean, many of the students or say many of the researchers are working on that, smart dustbin or say IoT-based dustbin, right?
Yes, sir.
The good part of your application is that you prepare, I mean, you prototype your prototype, you develop the prototype that is for our public dustbin, I mean, specifically in our country or in our state, right?
Yes, sir.
So have you tested it? Tested in the sense, in real applications, real life, have you tested it?
So we have tested it in our university dustbins for now.
That's why I'm asking you. What happened? University campus, right?
Yes.
That is private campus. Private campus in the sense that governed or that managed by the trust or say organization.
Yes, sir.
Right. But in that case, what you have to do, for example, suppose you put your dustbin in a public place like a bus stop or say pickup stand, right?
Yes, sir.
And then after see the effectiveness of your application.
Okay, sir.
So why I'm telling you, because our application should be robust, right?
Yes,
And
sir.
especially in our country, that is difficult, right?
Yes, sir.
So make it, test it, and use it. So you
Okay,
will
sir.
be faced with lots many challenges also, and overcome that challenges, and then your application or say prototype will be a best or say good one compared to the other existing things.
Okay, sir.
Okay. Fine.
Thank you, sir.
Thank you.
I
Okay.
take your
And all
suggestions.
the best for your.
Thank you.
Yeah, thank you, Drupal, for your presentation. Now I'd like to invite next presenter. Next we have Prisha Tandon, and she's going to present on robotic operating system based ground control station for unmanned aerial vehicles.
Good afternoon, everyone. I am Prisha Tandon. I'm sharing my screen with you just a few seconds. Good afternoon, everyone. Am I audible?
Yes, Prisha, you are audible.
Yeah, I am Prisha Tandon from Dayananda Sagar University. Today, I will be presenting our research on a ground control station software for unmanned aerial vehicles. My co-author in this research paper is Laranya Subudhi, and we are guided by our professor, Divishri ma'am and Deepthi ma'am. This research focuses on developing a robot operating system based ground control station for unmanned aerial vehicles, improving real-time control, surveillance, and automation. Unmanned aerial vehicles are becoming increasingly important in various sectors, including defense, agriculture, and disaster response. However, controlling UAVs in real time and integrating advanced surveillance features remains a challenge. Ground control station allows the operators to monitor and control the unmanned aerial vehicles remotely. Our research base mainly focuses on building an efficient ground control station using the robot operating system. The unmanned aerial vehicles can operate under manual control or autonomously using onboard computers like Raspberry Pi, NVIDIA Jetson, etc. The main goals for our research are to develop a software to control UAVs through a network, integrate live video streaming from RGB and thermal cameras, enable gimbal control for multi-angle surveillance, and implement snapshot and video recording features. Our system is built using PyQt5 for graphic user interface development, robot operating system for handless communication, and Python 3 is our core programming language that we've used in the research. PyTorch and OpenCV for image processing and object detection, and MAVROS is used for communication with UAVs via MAV link. So this is the flowchart for the total flowchart for our methodology, which we implemented in our prototype. The ROS master runs on the onboard computer of the UAV. The onboard computer, for example, we've used Raspberry Pi or NVIDIA like Jetson. Live video is streamed to the GCS interface. Users can control the drone using commands sent via MAVROS. Object detection and tracking are done in real time using AI models. Various sensors like GPS, IMU are used for flight stabilization and navigation. The ROS master node starts on the UAV's onboard computer. The GCS connects to the UAV via serial Wi-Fi or telemetry link. GCS processes telemetry data and displays it in the PyQt5 interface. Users send control commands, example takeoff, land, waypoint navigation from the graphic user interface. The UAVs, RGB, and thermal cameras stream the video to the GCS using the robot operated system image topics. OpenCV processes the video from the video feed for frame enhancement. The PyTorch base is for deep learning models. Sorry, PyTorch is for tracking objects of interest like vehicles or like people to object vehicles or people. Hmm. Users can send joystick or keyboard inputs to control the UAV. The UAV follows pre-programmed waypoints sent via MAVROS. The GCS interface allows gimbal control for multi-angle surveillance. The system logs flight telemetry data for post-mission analysis. Videos and snapshots are saved for review and processing. Okay, this is the slide, the methodology I just explained. Next is the applications, like the uses of our prototype. It will be used in defense and military for surveillance and target tracking, for crop monitoring and pesticide spraying. It can also be used for disaster management, search and rescue operations, infrastructure inspection like monitoring wind turbines, power lines, etc., logistics and delivery, automated cargo transportation. These are the various applications it can be used for. The conclusion of our research is we developed a ROS-based ground control station for UAVs with real-time control, object detection, and surveillance capabilities. This system can be applied in various fields and provides an efficient solution for UAV management. In the future, our team, we aim to integrate multi-UAV support, improve AI models for tracking, and we optimize communication. These are the references we used for our research paper. Thank you everyone for your time. My roommate Laranya Subudhi will be happy to take any questions. Thank you.
Good afternoon. Myself, Laranya. I'm ready to take any questions.
Sir, do we have any question for this presentation? Rajan sir, do we have any question for this presentation? Okay, Prisha, might be there are no questions for the presentation. Let's move forward for the next presentation.
Thank you so much.
Thank you.
Thank you.
So next we have Anurag, and he's going to present on the future of profitable farming, a review of Agritech Navigator's impact. Anurag, are you there?
Yes, sir. Good afternoon.
Yes. Good afternoon. You may please proceed with the presentation.
Thank you for your opportunity. So let me share the screen. The screen is visible, sir?
Yes, it is visible.
So good afternoon, everyone. So I am going to present on Agrotech Navigator, cultivate profit through futuristic farming assistant for profitable farming, along with my team members and respected Dr. Sandeep Chawre sir and Jayesh Sarvade sir. This will be table of content on today's presentation. So let's start it. Agriculture remains the backbone of Indian economy, contributing 7.66 to GDP of 2023 to 2024 and employing over 50% of the workforce. Despite the declining share in GDP, agriculture is indispensable to India's social economy framework. In 2020, approximately 55% of the workforce and over 65% of the population were engaged in agriculture and allied sector. The sector is highly dependent on unpredictable climatic conditions, affecting the productivity and stability. To ensure sustainable growth, the adoption of modern technology, precision farming, and agriculture education is essential. Agriculture supply and demand fluctuations are major challenge due to unpredictable weather conditions and market uncertainties. A predictive model is essential to estimate crop supply and demand, helping farmer make data-driven decisions. Our proposed system integrate real-time weather data and machine learning algorithms with market market demands. This system aims to reduce financial risk and improve farmers' profitability. The model helps in strategic planning, ensuring optimal resource allocation and sustainable agriculture practices. So we won't get into this literature survey because of less time span. We continue with the limitations. Talking about limitations, this study defines the factor considers only specific environmental factors such as temperature, humidity, rainfall, soil nutrition, nutrients, and pH. Other factors like irrigation methods and pest infestations and fertilizer uses are not included currently in our model. And while integrating the weather API for real-time weather data, it is quite difficult. And while the paper discuss demand, supply and demand, it does not account for unpredictable market dynamics. So objective of our project is about develop a smart agricultural advisory system that integrates real-time weather data, market trend analysis, and machine learning algorithms such as decision tree algorithm, SVM, to and ensure accurate crop supply and demand forecasting to support data-driven farming. It incorporates chatbot technology to assist farmer in making profitable decisions and optimize agricultural productivity while ensuring better market alignment. This is our proposed methodology where input layer farmer this is the core of the it indicates the system is capable of receiving inputs in two primary modes. One is text and another is voice. The farmer can type their query using keyboard, and farmer can speak their query while leveraging speech recognition technology. Processing layer handles the core logic and intelligence, converting the farmer inputs into actionable agricultural advice. First, input processing, what processing layer will do is it will take input from the farmer and the system uses chatterbot for natural language processing, allow farmer to interact via text or voice. The system extracts crucial details like location, temperature, soil, market trend using external data sources, and it analyzes the parameter to recommend best farming practices based on demand, supply, and profitability. We uses the machine learning algorithms such as decision tree and SVM. This algorithm classifies farming types based on input feature, improving decision making. The decision tree algorithm is a rule-based classification model that helps in decision making for farming. and uses input parameters such as soil type, weather, and crop type, and market trends to create a structured hierarchy of rules. Farmer can use these rules to identify the best farming practices for their specific conditions. Support vector machine is a supervised learning algorithm for classification and regression tasks work by finding an optimal hyperplane that separates the different categories such as suitable and unsuitable farming conditions and help classify farming types by analyzing features like temperature, rainfall, soil quality, and past yield data. These algorithms play a crucial role in predicting crop demand and supply, ensuring optimized decision making for farmers. So these are the layers we talked about recently. Output layer will give output through web interface, and it provides the uh, insights to farmer about demand and supply, about the average price of crops, and top crop to be cultivated for a particular piece of land. So conclusion, some marginal farmers in India still use outdated technologies because they can't afford better alternatives. In order to help a farmer increase their income, our model will help, our virtual assistant model will help them in profitable farming. So our expected result would be using ML algorithms such as decision tree and SVM. Uh, Farmer can receive tailored crop recommendation based on climate, soil, and market trends, and making the system
This
and
is a
making the
7
system
minutes
analyze
reminder.
demand. Yeah, ma'am. I'm ending it. The system analyzes demand and supply, expected yield to align crop production, and a user-friendly chatbot that can directly interact with the farmer via web-based interface. These are the references. So I kindly request Mohit for accepting further any questions. Thank you.
Thank you, Anurag. Are there any questions? Okay, since there are no more questions, we'll be moving forward.
Thank you, ma'am.
Thank you. Uh, just a minute. Am I getting it?
Madam, please proceed.
Yes, sir. Yes, sir. Just a second.
आपल्याला शोधलंच नाही.
Yes. Moving on. Moving on, I request Priyanshi Desai to kindly present her paper titled Voice-Controlled IoT Devices, a comprehensive review of cybersecurity challenges. Priyanshi, do we have you with us here?
Yes, ma'am.
You're not audible. No.
Hello.
Yes, yes, now you're audible. I'll stop sharing so that you can present your screen.
Yeah.
Yes, please go ahead.
Is my screen visible?
Yes, your screen is visible. You may start.
Yeah. Good afternoon, everyone present here. My topic for the presentation is voice control IoT device, a comprehensive review of cybersecurity challenges. Many of the things have been now IoT, many of the IoT devices I've been used recently in many of the households or anything like which are voice controlled like Google, Alexa, and something. Starting with the introduction and motivation. Topic for introduction is overview of a complete IoT device, including the smart homes, healthcare, and the industry used. Context and relevance. The growing relevance on these devices are critical security concern affecting the privacy of the users or the industries. The gap for the research are been the study existing for mitigation challenges or the cyber security, you can name it as. The research problem and the objective is how can we address the cyber security threats, like if someone is using the smart home appliances like IoT devices, but which are the Google, Alexa, or something that can be accept any voicing that we speak about. Like if I own a device and I order something, and another person who is visiting my home can also order that IoT device, which has less security for the users and everything. Objective is the key vulnerabilities and attack vectors, current mitigation techniques, and the advanced security measures. The review and the background. Reviews are like about the studies on voice snooping, insecure APIs, and data privacy. Workings are like expanding the frameworks, emphasizing the innovation for biometric methods, which provides the more security. The encryption or many things can be added for the security purposes. Next is the methodology, which helps to analyze the attack vectors. The steps are the vulnerabilities and the mitigation, which can be mutually seen and can be updated. Tools and data, the which are being used are the reports, journals, and the case studies on the IoT ecosystems which are available. Data collections are like the examples of attacks which have been done on the IoT devices and many more. The result regarding it is the analysis and the results are regarding the key vulnerabilities, which are the insecure APIs, the data retention risk, current techniques while effective and lack of resilience against the evidences, the significance demonstrated needs for biometric and all these stuffs. Comparison contracts between the prior studies and highlights the gap in the detection and oversight. Discussion in this is been done regarding the tax and mitigations, mostly with the example like the attack vectors are been there that are over the air updates, physical attacks, voice data, eavesdrops, and the adversarial attacks. The vulnerability contains are the voice snooping, man in the middle attack, and the data privacy risk. Insecure APIs are being included as the vulnerabilities. Then comes the limitations and further works. Limitations are the secondary data which are on reliance that goes, like IoT device contains a cloud data that goes to clouds and then come back as a answers or the required stuff. And the further research would be development of quantum resistant encryption and the biometric authentication. Concluding with the summary, the study identifies the vulnerability mitigation strategies, suggested future security measures for the IoT. Significance are the ensuring safer adoption of voice control devices for the daily life. And closing statement is securing IoT is not just about technology, it's about the safeguarding of future. Thank you. Any questions?
Hello.
Yes, sir.
Hello. See,
Yes,
I
sir.
have only one question. I have only one doubt regarding your security challenges. I mean, the work, entire work is a kind of the survey or say review kind of the things. Am I right?
Yes, sir.
So, as a student, that is okay, fine. But what I'm insisting you ki you have to do the survey. See, security field, it is not a small things, na.
Yes, sir.
So in depth, if it is possible, then give it your contributed work in terms of research survey, right? In depth with the different dimensions, so that can be utilized, that can be helpful to the other researchers or say for further work on the students.
In paper, I have included the examples which I have surveyed, or can be said that I have viewed also personally. So I've included some of the examples in paper.
That is fine, but real scenario, that is a different thing, na. See, have you referred any other survey paper from these research journal papers?
One of the I've referred it for the
Yes.
example point of view,
Right.
but not
So you
all
just
the
think
papers.
that's why I'm telling you. Just think about that. How many pages are there in that papers? In the depth. Lots many. There are many number of the pages are there. And here, what happened? We have limitations, na. Ki within 8 pages, 2 column, we have to complete our manuscripts. Am I right?
Yes, sir.
Right. So in that case, that's why I'm telling you. Presentation, you include some pictorial views that gives you 2 or 3 pages of work in a single images or say tables.
Yes, sir.
है ना? Okay, so this is my suggestions. Okay, fine, thank you.
Okay, sir. Thank you, sir.
Thank you, everyone. Just a second. Yes. With that, we are done with the presentations of the day. Thank you to all our presenters for their insightful contributions. And before we move forward to our closing, I would like to invite Dr. Rajan to share his thoughts on the presentations of the day. Over to you, sir.
Hello, am I audible, ma'am?
Yes, sir, you're audible.
Okay. See, although the presenters are very good, the work in the contributed work of the researchers, or say a few of them are the also students of undergraduate or the post graduations. The work is okay, fine, good. But I would like to tell you, in all general suggestions, that is the normally what happen. We people are belonging to representing our nation, our societies, right? So for whatever the work, whatever you do it, so do it for the nations or say for the society, that can be helpful for us, right? In earlier one of the presenters, I gave the suggestions ki use the our nation's images and work on that one instead of using the other foreign images, right? So this is the a little bit kind of the from my message from my side. This is what you can say message, and all the no, all the researchers or some PhD students, all the best for your future or say career, and probably do the work. That work should be a genuine work or say follow the research ethics, right? Okay, thank you, madam.
Thank you so much, sir. I sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for support during this ninth version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026 as well. All the presenters would be getting their digital certificate through email within 2 working days. Further, all the papers have already been forwarded to this printer. The publication will be live within 6 months. Kindly cooperate with the team of SmartCom 2025. I also thank our session chair, Dr. Rajan Patel, for chairing the session. And here's a small token of appreciation from the team, sir. On behalf of the team of SmartCom 2025 and Global Knowledge Research Foundation and partners. Thank you everyone for your valuable presence. I kindly request you all to switch on your cameras for a quick snapshot of the virtual conference. Yes. Is everyone ready? Wait. 1, 2, 3. Thank you, everyone. Thank you for your presence. Please have a great day. Bye. Thank you.
Thank you, Rajan sir.
Thank you, Rajan sir.
Thank you, my pleasure, and I'm also thankful to the SMARTCOM, also the entire organizing team. Thank you, and I'm also
Thank you.
sorry for that late joining due to the some
Not
science
an issue,
schedule.
sir. Not an
Not
issue.
an issue, sir. No worries. No worries.
Okay,
Thank you so much, sir. Have a great day.
Sam too. Thank you very much.